Imagine you're trying to solve a massive puzzle with millions of pieces. You could use a single expert puzzle solver who works meticulously, one piece at a time, or you could assemble a team of thousands of puzzle solvers who work together simultaneously. This is essentially the difference between using a CPU and a GPU for deep learning tasks. In this world of artificial intelligence, understanding which tool to use can be the key to unlocking incredible breakthroughs. Let's dive into the fascinating world of CPUs versus GPUs in deep learning. Let's start by explaining what CPUs and GPUs are. CPUs and GPUs are both crucial components of a computer, but they serve different purposes. A CPU, central processing unit, is like the brain of your computer, handling most tasks from running applications to processing data. It is designed to perform tasks sequentially, one after another, and excels at handling complex logical operations. This makes CPUs excellent for tasks that require precision and logic. On the other hand, a GPU, graphics processing unit, was originally designed for graphics rendering but is now widely used for tasks that require many calculations simultaneously, known as parallel processing. GPUs are akin to a team of workers who can perform many simple tasks at the same time. This parallel processing capability makes GPUs ideal for tasks like deep learning, which involve large datasets and complex algorithms. In the context of deep learning, CPUs and GPUs handle tasks differently. Imagine a skilled chef preparing a complex meal, where each step is done carefully and sequentially. This approach works well for small tasks but becomes slow when dealing with large datasets. CPUs are not ideal for parallel processing, which is essential for deep learning. In contrast, GPUs are like a factory assembly line where many workers perform the same task simultaneously, handling thousands of calculations at once. This makes GPUs perfect for deep learning tasks that involve large datasets. To illustrate this further, consider training a neural network as building a large Lego structure. Each Lego brick represents a calculation. A CPU would place each brick one by one, which is precise but slow for large structures. In contrast, a GPU would have a team of builders working together, each placing many bricks at the same time, making it much faster for building large structures. The key differences between CPUs and GPUs can be summarized as follows. CPUs handle general tasks and sequential processing, while GPUs are optimized for parallel processing, graphics, and AI. CPUs have fewer but more powerful cores, whereas GPUs have thousands of smaller cores. CPUs have high clock speeds for sequential tasks, while GPUs offer high throughput for parallel tasks. CPUs are less efficient for large datasets, whereas GPUs are ideal for large-scale parallel computations. In summary, CPUs are versatile and good for tasks requiring precision and logic, while GPUs excel at parallel processing, making them ideal for deep learning and AI applications.